Welcome to the Decode Podcast. This is Rev 1.9. Thank you, everyone, for joining us. My name is Daniel Stanfill from Aurora Boardworks. Elias, would you like to introduce yourself?
Yeah, Elias Malpabon here with Metal Etch Services.
Sean Kincaid with K&F Electronics.
And our guest today is Caleb Chenoweth from the company name is Genpack. He's the Director of Technology and EMS Operations at Genpack Assembly Services. So, Caleb, just to start off, why don't you give us a background of how long you've been there, kind of how you got your start there, and just in general, what you like about working there.
Yeah, well, I appreciate you guys having me on the podcast. And this is actually going to be my 10th year at Genpack. It's funny enough. So I started there. I'm 27 now. So I started there just after I turned 16. Back in high school. So
high school job, huh?
A decade ago, yeah. So just ironically, it was just kind of a job there working on some of the hand soldering, because I was familiar with it from high school. We had a tech course where I was kind of had my first introduction to electronics. And I've always been kind of tech oriented and always been, a gamer back in the day. So that led me into that. And so that was my high school job, just a part-time job until when I graduated high school. I decided to kind of take a year off and kind of figure out what I wanted to do towards if I wanted to go to post-secondary or whatnot. And so in that, time frame, I worked full-time there. And that's kind of what led me to branching off away from just being, more or less, a lead hand operator, and went into the surface mount line. And so I had my introduction to, we had a Samsung pick and place machine at the time. And that's kind of where I had my start, just, loading feeders. And, at the end of the day, it was still a part-time job or a full-time job at the time, but it was really just, an operator. I was really just kind of following direction. And so I decided to go to college for software programming. So I did a 3-year course for software engineering, got my degree in that, and unfortunately hated it. Realized fairly quickly that I did not want to sit at a desk for the rest of my life and more or less sit there at code and look at languages I couldn't actually speak to other people.
I get that.
Yeah, so it was, I had a good opportunity in the government during a co-op, and really that led me to an IT job at the time. And so that was really what kind of kept me sane, for the lack of a better word, because I was very hands-on there, building computers and fixing printers. And again, it was electronic oriented. And so that's kind of where I thought maybe I should kind of go back full-time here at Genpack. And so then again, I decided to kind of work my way back to the surface mount line and really start establishing myself as more or less a process engineer. So really, I'm a pretty competitive guy. So I like to always, improve and kind of make things better. And so every time circuit board would come out of the oven, I would try to think of ways that we could make it better. We could make things faster. And I just kind of always was competing with myself of, how fast can the machine go? How can we re-optimize it? And that just kind of fast forward 10 years. And now I'm kind of the head of the EMS division. And now I'm kind of more around the operations and business side, because I've kind of fallen in love with the whole entrepreneurship and just kind of learning the business side of it.
Well, you're obviously no slouch. All of us have talked to you. You clearly know what you're talking about. I know our conversations first started, I don't know if it was our first conversations or if it was very soon into talking to each other. I ventured out a guess. I had recognized you I'd put 2 and 2 together, did some detective work, and figured out that you must be somebody I had actually communicated with in some other forum online, just talking electronics, talking pick and place equipment. And I was like, hey, I like your stuff on LinkedIn, and if you're who I think you are, I like your stuff on this other forum too. Are you that guy? And we just started talking about everything, pick and place, selective soldering, whatever. We connected like that right away. So I'm certainly a kindred spirit on everything you've been saying so far. That was my start at our company was on the pick and place lines, and I kind of just loved the technology from day one, and couldn't help but just think of constant ways to try to improve it. Also, it's a rapidly evolving. All the technology involved with it is rapidly evolving. If you're not paying attention to the latest and greatest technology, you will quickly get left behind.
Yeah, that's certainly the case, and I think that'll lead us to, I'm sure, a deep conversation around overseas manufacturing, because I think that's a big misconception a lot of times when people look at overseas is a direct one-to-one labor rate, and truthfully, a lot of times because it's cheaper there, it's a lot of times their technology is a lot better and they've automated. There's a lot of people here in North America have started to kind of realize that the way to compete is not pay people cheaper, it's to assist, people at producing faster. It's throughput.
Yes.
So it's robotics. Yep. But it's not, again, it's the misconception of it's not replacing jobs.
They'll
but
take our
at
jobs.
the same time, it's assisting us do more and be advanced, because that's what, frankly, China's doing.
Yeah. Like if we were to get a robotic through-hole insertion machine, it wouldn't send people home. It would give all of us more to do, actually. It'd give everyone here more to do if we had one of those like super sweet, modular, flexible through-hole insertion machines where you can just basically put virtually any type of component straight off of the whatever type of packaging it comes in. If you had something like that, you're not hurting anyone's job.
No doubt. And again, that even leads us to like where, in our through-hole line, we have a selective solder machine. I kind of refuse to bring wave in-house. And a lot of times it's just because there's a lot of benefits to selective and you can kind of utilize wave within it, right?
You can mimic it, right?
Exactly. But with the selective, the one I chose to use specifically, we basically have a turntable operation. So when, the table, it basically does a 360-degree turn. And so therefore, when a board is in the machine, being soldered, we can be loading another board and actually stuffing the board. And that was one of the big throughput changes we did to kind of compete from a competitive perspective, was to lower our throughput, because we've basically combined our stuff line and our solder line into one process.
Yeah, I know the exact machine you're talking about. I guess I'll just kind of put you on the spot. Do you feel that there's ever a acceptable time not to preheat an assembly before selective soldering, or do you put every single board under a preheat cycle, and is it kind of already predetermined, or does it depend on the assembly? Like, what's your process in determining your preheat?
Frankly, trial and error. But a lot of times it's definitely assembly dependent. There's obviously kind of a baseline that we start with. But the reason I say trial and error is there's never really a rule of thumb based on the assembly, because there's always some nuance to it. I have a board, for example, where we don't preheat, and the reason is because two reasons. It's a very thin board, so real quickly, regardless of a jig, it wants to bow. And it's a super thin LED board, and so there it also lends itself to not really needing to be preheated. It's a 2-layer board, and it's very thin leads, and therefore the heat that's coming from the selective solder is more than enough to get you very perfect hole fill, get you topside fillets. And on the flip side, your potential with preheat of burning the LEDs from above is probably not worth it on that side. But I mean, generally speaking, yeah, preheat is definitely the way to go. It's just I've found that it's kind of a nuanced thing where I've had even like relays want to burn under IR preheat. So I lend myself sometimes to actually stalling or selective solder under one of the holes to let the hot nitrogen preheat the board. It's also a really good, you
Heat
find
it
that
locally.
Exactly. It heats it locally, and I find it just lends itself to giving you better soldering results too, because you're basically coating the board with nitrogen. So you're really eliminating any of the oxidation around it.
So what do you just increase the dwell but lower the Z height? Trying to figure out how I would program that. That's a good idea.
Yeah, basically, so on our machine, you can program. There's what's called like there's the Z speed, and then there's an approach speed and approach height. So essentially, the machine has like a standardized speed that it'll approach to, but then you can put in basically a secondary Z height, so that let's say 10 millimeters, for example, the machine will go to 10 millimeters and then it'll slow to whatever speed you program it to. And therefore, you can basically put a very slow speed. So as it's coming up, you're essentially not touching the board for X amount of seconds. There's also, I know in our machine too, there's literally the ability to do localized preheating. So you can actually hard code in the board that at every solder point, it will wait X amount of seconds. And there's even an adapter that you can buy that basically has a little circle IR preheater right around the nozzle so that it's always localized preheating under the board.
How many more you want to do? There's a lot more features. Like, that machine's pretty sweet.
Yeah. It's pretty endless in terms of what you can add to it. But like anything, it also real quickly starts to jack up the price as you start to add things.
Always
It starts
does,
to get pretty
right?
unreal.
Always does.
Yeah, real quickly we learned, because I wanted to kind of have the luxury of, because we changed our solder baths from Rojas to leaded sometimes on our selective. And, you know, even it being a selective machine, that bath is still probably 55 pounds of solder, plus probably a good 25 pounds of actual iron equipment there. It's quite the pain to do a solder bath change. But at the end of the day, you get a couple strong guys and you do the bath change, because the flip side of that is like an $11,000 tiny little trolley that'll pull it out for you. So that's kind of the trade-off.
Have you seen it? It's slick.
It is. I will give it them. It is pretty nice, and it preheats your bath too. So that's the beauty of it, is you can change. So
like,
your
if you
bath
want to do
while they're
maintenance
hot.
on it, you can have it out and hot while you do. Like, it's pretty. Yeah.
You can basically do like the same way that, like, you know, on a pick and place you have your docking carts. You can just do a quick change and be up and running within 10 seconds, the time that it takes to get the nozzle wetting back. So it's pretty incredible.
What brand is this? I want to know.
Pillar House.
Pillar House? This is amazing.
Yeah, they're based, they're UK made, but then they have a field office down there in Chicago.
Yep. Which I've been to the Selective Soldering Academy, and have you also, Caleb? You haven't. You just know Eddie and Jonathan. And...
I was fortunate enough to be trained by Eddie, so he's the leader of the Selective Academy. So he came up to our facility for over a week, and he installed our machine, and then gave me a full training.
You must be pretty important. Like, Eddie's a big deal. So
yeah, I was pretty fortunate.
Yeah, that's cool. The Selective Soldering Academy, they've got a pillar house there. I mean, it's a pillar house organization, you know. I mean, they run it, but the cool thing is, like, it doesn't matter what machine you have, they just teach you straight up fundamentals of process related, like everything you want to know about flux, everything you want to know about solder, everything you want to know about the process of diagnosing defects, looking at it under a microscope to figure out what you're looking at and be able to diagnose and determine what parameter to change. I will heavily endorse that class. Any operator, any selective solder operator, technician, programmer, just anyone should go to that class. You learn a ton. Like, it's pretty cool.
So, Caleb, we've gotten kind of close to mentioning it a couple times in the conversation so far, but maybe it's not known. You are in North America, like you said, but you're in North America, right? So maybe just tell us a little bit about where you're located geographically, and so the audience is aware. Yeah, so where the good old polar bears sleep, we're out here in Canada. So unfortunately, no polar bears. So we're in southern Ontario. Just located about an hour away from Toronto, so a lot of people know where that is. It's actually not too far from our buddy down there, Sean. But yeah, we stay up here. It's starting to get a little chilly, but fortunately, it's kept us pretty. We're in a close spot because we're about an hour away from the border, from the Buffalo border, so we can service kind of both our North American partners in Canada and America. So you are conducting business on both sides? We are, yeah. We've kind of kept our niche market to Canada and the U.S. for the time being.
Did you guys know that before we invited him? Did these guys know he was a United States competitor before we brought you on? No, right? I'm just kidding.
Yeah, watch out. I'm coming for you guys. We're eating up the market up here, so we're going to have to come down there now, right?
No, that's cool. I've always told everyone in this industry, like, you know how it is. Like we've shared so much knowledge with each other just in our conversations. Like I don't look at anyone in this industry as a competitor. I look at everyone as a potential friend who won't turn me down on a conversation about, you know, SMT equipment or whatever. Like anyone who's like as invested in this as I am, like I love talking to. Like I know these guys are the same. That's why we click for sure.
Yeah,
No, I 1,000% agree.
steel sharpens steel, right? I strive to be better when my competitors are doing better.
Yeah.
Otherwise, I'm lackadaisical, you know. They elevate my life by watching how they're doing theirs, you know.
1,000%.
It's
Well, and
deep,
that's
bro.
the big thing, right? Like business at the end of the day is it really is just a game, right? And so it's just a game of competing. But in the same vein, it's we're all in it kind of together. So I find a lot of times that it's like a video game that you get the odd companies out there that like to lie, cheat, and steal. But in the same vein, what accomplishment does that get you? And generally speaking, they don't last very long.
Right.
Where on the flip side, if you can kind of make friends with everybody out there, it's only going to lend you in the positive way. So.
Yeah, and for the most part, I doubt we've ever had a customer cross each other's, you know, like that one that does work for me and for you. So are we really even competition, you know?
Well, I think that's the crazy thing I find because I'm sure you guys have seen it a lot more, but being up here in Canada, the market compared to the U.S. market is quite small. And for perspective, California is about 4 times the electronics market than all of Canada, right?
Wow.
Yeah, it's when you consider there's from my understanding there's more CMs in just the Ohio region than there is in all of Ontario. So
Wow.
Uh,
We got 40 EMS companies in Metro Detroit.
wow.
Too many.
There's probably not 40 within 500 square miles of me.
but see, it's an interesting dilemma though, right? Because I feel like in the States there's not a lack of work in terms of there's always kind of something being developed. There's always something that needs to be made. Where that's I think a lot of times that's what we find with a lot of the other CMs is they're kind of always hunting and chasing for the next thing up here, because at the end of the day a lot of the innovation is happening down there in Silicon Valley and elsewhere. New York has been a nice hub for us that we've seen quite a bit lately. But yeah, from that perspective, it's definitely can be a tough market up here.
I'm going to take the conversation backwards. What about selective solder programming? Do you do that? Do you tend to do that offline or online? Do you like doing it at the machine or using Gerbers? What's your preferred method?
Generally speaking, we do it online and we do it like directly on machine, like without Gerbers. So we'll do it from the cameras. We'll take a top side and bottom side image of the board, so at least we have like an actual 3D map of the board, and that lets us at least give the ease of clicking around the joints. But yeah, most of the times, I basically have a folder with a bunch of like standardized nozzle profiles that I have, and that's kind of our starting base. And then again, as we kind of run a couple boards, then we cater towards them as we see fit.
So that was one of the things I was going to say, Sean, is that Pillar House platform has a lot of features that are already built in and super easy to use, where they just have this functionality that, you already have a box there that you just assign a variable to, and it just does this amazing thing, like the pull off, like the approach or the pull off, or just all kinds of things. Like the nozzle offset, just so many. But you learn these things, and even if they aren't a one-to-one direct relation to the machine that you have, you can still apply the principles that you learned from it. And at least with my software, it's a lot more clunky than their software, but you can still teach it to do the same thing. I can still achieve a pull-off, just I don't have part of the proprietary software that just makes it super easy. I just have to make it happen a little bit more of a dirty method, but it performs in the same manner, just takes a lot more steps on my part to make it happen. Anyway, get sidetracked on too much process stuff. These guys will get kind of bored, but
you're fanboying over that selective.
If I can't buy one, at least I'll try to get somebody else to buy one. They're sweet.
I like mine. It's super easy to program. Much like Caleb said, you take a scanned image of the board. You don't have to use anything fancy, but we have a PCB reverse engineering scanner, but you could use an Epson or, Brother scanner, and it would scan fine. You scan the image, you assign your origin point, and then you draw your flux paths and your solder paths. And then when you program the job, you run the camera up to where your origin point is, click it, and then hit start. It's super easy. But, like you guys are talking about, Daniel is too, if I want to do a pull away, I have to manually type in, what do I want the Z height on this? How long do I want it to dwell? How long do I want it to, how fast do I want it to go through the joints? And that you kind of have to learn. If you're lucky, you can get it right on your first pass, but sometimes it takes a couple tweaks to the numbers that you've drawn. But ours is super easy. I can program a lot of pins really quickly. And in fact, I just found out mine comes out with a $16,000 attachment too. I think it's 16. I don't know. Don't quote me on that. But it turned it into a 2x2 or a 4x2 square that instead of your selective solder, if you just had a bunch of pins and there's no surface mount parts, it's literally just a square and comes up and fountains over the whole thing. And I have an 8mm, and I tried that before. Not the best luck, but I never thought about pausing it before it hits those pins. That would give me some good bottom side preheat just by, that thing's 300 plus coming out of there, 315 on the nitrogen. So that might be achievable. I don't know. You're always looking to speed it up, always looking to be faster, but you don't want to have a bunch of bridging afterwards,
You guys have said pull off or pull away a couple times now. Is that kind of referring to how you exit an individual component? You get to the last pin and how you exit that? That's exactly what it is. And another word for it too is really debridging. So I know there's a couple companies out there that have they call it their debridging tool. So a lot of times there's some companies that will blow a nitrogen at it. So therefore, as it gets towards the end of the joint, they're blowing hot nitrogen at it to kind of get that bridge to separate. In terms of kind of what more Daniel and I are talking about on the pillar house, what essentially you can do is you have what's called your solder RPM, and that's how fast and what gives you your flow to come out of the nozzle. And there's a setting called pull off, is an RPM that you program that's generally 30 to 40 RPMs lower than that. And what that does is it basically pulls down the solder away from the joints. And because
without the Z height really changing.
Exactly. And what that, leads itself to doing is, because your nozzle is obviously wetted and it's generally bigger than the joint you're soldering, just physics works to itself, and all the solder wants to pull down and pull off from the joint, and therefore you have no bridge, ideally anyway.
Yeah, it works really sweet when if you've got a dual row header or pinner, you've got 2 rows of leads
connector,
and you get to the very end, and those last 4 or last 2 or however you want to say it, want to bridge together, because what happens is, as it goes from lead to lead, that next lead wants to grab it and pull it. And when you get to the end of the row, there's no more new leads to grab that solder and attract it. So it stays, if you just run straight off the end of that row, there's a good chance those last 2 are going to bridge together. So if you run it to the end where the wave is kind of overlapping, or right in the gap between the last 2 leads, if you run it to that point, the solder RPM's lower, it just kind of does its magic.
See, that reminds me, have you guys ever seen, I've seen it on a couple boards, is debridging pads. So at the end of long rows of leads, they'll actually have bare pads at each end, and it's basically
awesome.
To do that exact thing.
Intentional solder thieving. Yep.
Exactly. Yeah, there you go.
Mm-hmm. It's an awesome design feature that hardly anyone does. It's so useful.
Yeah.
Another thing that's kind of surprising that helps is actually silk screen lines. You can actually, if you actually have like thick silkscreen lines in between the leads, that helps to break that capillary force that
It acts
causes
almost
the
like a solder
bridging.
dam, like a higher solder dam, exactly. See, one of the more lesser known uses for pull off, and it's more of a nuanced case, but we do it a lot of times. It's usually from an aesthetic perspective because it helps our inspectors. But if you kind of have a poor pad design where you have a very, very large pad compared to joint, sometimes that leads you to having almost a very large ball of solder, right? And sometimes that even hides the lead, where therefore you can't do your inspection of seeing if the lead has protrusion. And so pull off will let you pull that solder down and suck back on the lead, and it gives you that really nice concave joint.
Clean fillet.
It's more of a nuanced feature because it's just an aesthetic, but it's definitely there's some use cases for it.
Welcome to the Pillar House Podcast. This is easy. Oh my God.
I don't even have one, and I'm the one
This machine's
promoting
amazing.
it. So don't worry, Caleb. I mean, well, you've said nothing but good things about it. I'm just saying we typically try to not go crazy, sponsoring one brand or whatever.
Yeah.
But it's cool.
That thing sounds almost too good to be true.
Well, as I'm listening to all three of you guys talk about this process, and I kind of get the impression that you all three could have the same exact assembly and break off on your respective
programming stations.
Yeah. And no, just the entire assembly. You could get on your selective, and your way of getting to the end result would be different for all three of you.
Probably.
100%.
Okay.
100%. There's virtually no chance that we would all create the exact same program on the exact same assembly. Like, no chance. None.
Yeah, and I think our approach would all stem from even different cases too, because I think, there's, from a material perspective, obviously we might use different solder pastes or different fluxes or alloys. And so that's obviously going to lead us to different parameters. But on the same vein too, I know it's also just going to be the way our minds think, right? So, the way we actually go around the board is going to be completely different in terms of, do we see something to lead it to a faster cycle time, or is this going to lead to a higher yield? So it depends kind of what your actual end goal is too.
There's times where I have actually enough time, the operator has enough time to fix the bridges. So it's better to just, hey man, at least tack these guys for me, and then we'll just crank them all out and then touch them up in inspection, right? There's times that's that too as well. It's a good point, Caleb.
See, I guess that'll lead me to a question then for both of you is with your selective, do you guys ever find that you're able to use it almost on a manual basis for rework or to fix or touch up?
I don't like it. I don't like it at all. JBC, since we're promoting brands this episode, they have their desoldering station. We hooked it up. It was okay at first. We had it like an electric pump. Then we hooked it up
to the same one now.
To the pneumatic though. We actually hooked it up to the airline. Night and day difference. I mean, you want to talk about right out like a connector. I can clean that thing out so much better. And you know how it is, Caleb. Pulling a connector off is always scary in the barrel, especially if it's a long one. And the biggest I have is a circle 8mm. So to pull that thing off, they do also sell, which we bought, these little square pads you heat up, and the board sits flush right on it. And you just put like a little bit of solder in there, and it heats up, and then you have like basically a moving melting bath right here of just tin going, and then you just drop your board on there and pull it right off.
Something to have one of your solderers do, Sean, is use like a heavy gauge wire, wrap it around all of the pins, and then heat up that really heavy gauge wire super hot, and then the whole thing drops out.
That's smart, yeah.
That'll pull out?
Mm-hmm.
So
if you have to rework one, if you have to actually remove one.
Are you doing this upside down?
Yeah.
Okay. Because I always do it from top down.
I was saying a different, not using the selective. I mean, I'm saying like if you actually have to like, worst comes to worst, and you have to remove one, you can get a really heavy gauge wire, thicker than your leads are, and wrap that to where it's touching all of them, like coil it if you can.
You're basically
And,
making like a heat bridge across, yeah.
And heat the whole thing up at one time together, and it just pops right out.
See, I find the thing that a lot of people forget too is hot air is your friend while you're soldering. So I find a lot of times people forget that you can, just go ambidextrous and hot air in the left hand, solder iron in the right, and that lends to a huge ability to kind of get through like heat sensitive boards, right? Or
Sean, are you mad at the technique or the word ambidextrous? What's going on?
I'm telling
Which
you,
is it? Could be either.
no. It's I thought of Orak when I heard him say that because he's so big on using both hands at the same time. I was like, he finally found the one who will carry on the torch.
Our shadow consultant.
Yeah.
Does Caleb know who we're referencing that we can't speak by name on the actual podcast because he likes to stay in the shadows? But
in the shadows, so
our solder paste expert.
We want to have him or her on. We'll even throw a little plot twist. Could be a girl. We want to put a...
Yeah, we definitely haven't said him a million times.
We should put him in a...
My method for rework on selective is to drive it, like, I can drive the camera to the location, then tell it to switch the camera with the tool, so then the tool goes right to that spot, and then I can manually drive it to the height I want it to. It's happened like maybe once, possibly twice in history, where an operator has forgot to stuff a component into the board. and so then the hole gets soldered without a component. Now how do you stuff it, right? So I can drive the wave directly to that joint, and it immediately makes all that solder flow. You just drop the component in, pull away. It's just like it usually looks like you had meant to do it, the first time or whatever. Every once in a while requires a little touch up, but super easy.
So did the three of you guys get together before I got on and just decide to talk about through-hole technology the entire time? Because
well, actually, that's kind of how we all kind of clicked for the first time. Was I tagged Daniel, and Europe was having some we're gonna have a hand soldering competition. And I was like, I challenge you, Daniel. And then Caleb came out of nowhere. I didn't even know him at the time. And he was like, all right, I'm in too. And
oh, you didn't know him at that time?
No, I don't think we really knew each other, did we?
I don't think so. I don't think.
Well, Caleb.
I bowed out before it started.
After I found out what Caleb, the smallest package size he has soldered by hand, I was like, it's not even competition.
just forfeited.
Yeah.
Threw in the white towel.
And I forfeited before I even asked.
Yeah. What is it? 0201?
Yeah, I can do 0201, and I can do, I think the thing that
makes without.
I don't use magnification either.
White flag.
Yeah.
White flag.
Yeah. So for perspective, we had a board recently where I had to rework, I think it was 24 0201s on a 9-layer, or it was an 8-layer board. So that was quite the fun one. And for perspective, those 20 plus 0201s, this was on a board that was 50 by 50 millimeters, and there was 350 0201s in total on it. So the bigger game wasn't reworking the single 0201, it was not disturbing the rest of them.
Wow.
Yeah, wasn't fun.
Talk about dense, man.
I will give them that. It's an incredible board.
Did it look like a
board.
BGA? With the pads?
Basically, when you look at the board, it just looks like a bunch of silver balls everywhere. When I show it to when I first brought it in-house, I would bring it to some people, and I was like, do you know what's populated right now? And they were like, what? And because they just think it was just a bunch of solder on it. So, yeah. It's a little bit of a pain.
What, that's like 2 inches?
Yeah, it's literally 2 by 2 inches, and it's a circle board too. So it's from every this is probably the most challenging board we've had to deal with. We've had some pretty large boards, some really high layer count, but just from the pure density, and it's a mixed technology board. It's double-sided, and it's very specific too because it's an analog board. It has high voltage on it. And they call it out very specifically. So based on IPC, every lead has to be trimmed flush and no sharp edges. So every joint has to be reflowed after you do through-hole soldering. So it's just the nature of it is it doesn't lead to hole fill at all because it's an 8-layer board. So you better have some preheat on it. It's quite incredible. And again, because it's a double-sided board, it really doesn't lead itself to selective solder. Like that's honestly been my challenge right now, and it's been fun, but it's trying to figure out a way to fully automate this board without, having poor yield basically. Because like we said, like with that many 0201s, really the name of game is yield. Because if you have to rework those boards, you're just out of luck.
Yeah.
And the cost, that's the bigger thing too. These aren't cheap. So that's the unfortunate part is it's not like a board that you can go, you know what, it's just a bunch of, 0 ohm resistors that you can scrap. It's like, oh, some of these resistors are very specific values and we're talking $2 a resistor. Like it's quite incredible.
That's insane.
But that's Canadian dollars. So that's like what, 2 cents to you guys.
So
we talked.
Go ahead, Daniel.
Well, I was just gonna say, like, Caleb brought up poor pad design, and like I don't want to throw anyone under the bus, like, and say that the board I was working on was a poor pad design, but I can say that the pad, the footprint that exists on the board now, does not support strongly the component that gets placed on that footprint. Like, I don't know if you guys have ever experienced this where over time a component goes obsolete, it gets replaced, and it's like basically a fit for the board, and they make something that's not like extremely optimal work without doing a rev change on the board itself, especially if it's like a product that has to get some type of special certification or type of, special listing or whatever. Doing that type of change is going to be like super difficult, long, expensive, arduous process. So have either of you ever experienced where you're dealing with a component that doesn't really perfectly match the footprint on the board?
Yeah, for me, the worst one is I have a customer that interchanges 805s and 1206s on these resistor pads that are already oversized a little bit for 1206, and then trying to AOI that thing. Oh my God, when they use 805s, you got this, you got that, you got this. It's just all over the map of just way too much everywhere. That's my worst one. When you start talking, it immediately flashes in my head. And then you look at it and you're like, man, what's going on? And then you're like, oh my God, these are way oversized.
See, I find, and this might be more, maybe you can chime in, Elias, because I think this kind of leads itself more to not only pad design, but stencil design. But I find the dual-leaded diodes, like SOD 523s, really don't like to center themselves unless you have like the most perfect pad design ever. I have one customer who I don't know how they've got away with it, because I've had other customers match their pads, and it must just be the thermal profile of the board. But though the SOD 523 diode that we assemble on it is perfectly straight every time. I've never had a defect. But I have probably 15 other boards that I don't know if I've ever seen one straight. And a lot of times they'll lead themselves to wanting to pull to one edge or the other. And kind of like what Sean said, it's a nightmare to AOI. Like, I find that our yield is actually probably 99.99%. We almost never have to rework them anymore. But from an AOI perspective, you would never know, because, one, it's like a flat lug lead. So the solder basically just kind of sits like a mountain on top of the lead. So there's no concave nature to it. So, when a lot of people look for the quote unquote blue that a lot of times signifies good solder joints, that's impossible to see here. And to kind of look at the way AOI works, once you understand how AOI works, it's really just based on color when it comes to the solder joint. And this joint leads itself to a bad joint and a good joint is almost impossible to see via color.
Yeah, like the way it looks on the toe, right? Like
exactly. You might be able to see almost like a shadow, like it where it basically looks like it's like a head and pillow. But otherwise, it's just a nightmare from a inspection perspective.
Something we've experienced with those components is, like you said, they function perfectly. There's no issue. They're on the pad, like they're well soldered, but they actually almost turn a little to where
Yep.
it's just now the lighting, the way it's hitting the top of the component, the imaging doesn't show up right anymore. It's hard to spot the identification. It's hard to prove the polarities right. And it requires manual inspection of it just to confirm it. And it's always right, and it's always where it needs to be, and but you have to verify it, and you can't do it without looking at it manually.
Yeah.
It's just kind of annoying. And it's not on all of our boards. Just like you said, some of them come out fine, some of them do that. I don't know what the difference is.
See, and you can somewhat get away with it if you have 3D AOI, just because you kind of get the nature of the side view, but I think it's still fairly challenging. But if you have 2D AOI, it's almost like you might as well supplement it 100% through manual inspection. And even there, to your point, it can be kind of a red fish, blue fish, where a lot of times, at the end of the day, people aren't perfect. So looking at that, over and over, you're practically going to miss some of them. So
mine is 3D AOI. However, this board is a black mask, and the finish that I get starting is hazel.
Oh, no.
And then I have it's actually the step stencil that Elias did for me in the video that I made, where there's a connector that needs at least, what do we do, 6 mil on that one, Elias?
6 mil, yeah.
Yeah, 6 mil, and all the rest we kind of have to shrink down because there's some small footprints on there, and and I got a buried Bluetooth chip on that one, and those
sure.
pads are pretty close together. But yeah, so I think the black mask on mine throws it off, and then the hazel finish. I get kind of like this sometimes, where it's kind of like a rotating a little. I don't even know how to describe it, but
well, and that's what I was gonna say to Elias is I think a lot of times from what I've seen is I think it stems from like it's not just the pad design, but I think it's from solder almost being under the body, and I think it's almost lifting the part up.
Yeah, so Daniel and I worked on this as kind of one of our initial collaborations, and it kind of started with a phone call, and Daniel called them skinny leaded diodes, I think, if I remember the term that he used. And so we looked at it, and
that was a super technical term that I used. Thank you.
Yeah, I saw the look on his face when I shared that term, and he's like, "Oh gosh." But we looked at it, and what's interesting is that the paste files for these components typically have a land that's roughly the width of the body of the component, right? But the actual lead itself is substantially narrower than that. So you're kind of throwing a lot of paste at it. And that's how the land on the board's designed. But the strategy that we've found to be pretty successful is to kind of reduce the width that you're actually pasting onto the board land. And I think that stopped some of the roll or movement of those components. Daniel can kind of give his take on that. What you've seen in terms of how that strategy's affected downstream.
Yeah, I believe the script you provided me says Metal Etch Services provided me with a sound. No, it was actually, it worked awesome. Like it worked great. We had immediate success the second we implemented the strategy. And when you work together on something like that, you don't know. When you start out, you don't know what the issue exactly is, and you get to the root of it, implement a change, and then immediately see good results. Like, that's the kind of stuff that, process engineers dream of.
Yeah, and you're talking about reducing the width of I'm pretty sure that's the smallest footprint I have on that board. So when you're saying to like reduce that even smaller, it's kind of counterintuitive.
Yeah, sometimes that is the answer, though.
Yeah, see, and it makes sense too, because it's funny, because like we had an approach where one time I thought maybe like the reverse U shape would be kind of the best foot forward for it, because it basically would only solder around the lead. But if I'm sure you've experienced, a lot of times these leads are cut, and so the actual edges of the leads don't lend themselves to soldering. So you really need that solder, especially with RoHS, which doesn't really want to spread itself across the pad. You have to have that solder under the lead and not just around it. and that was kind of a big fight we had with dealing with these components, was just really optimizing for proper like the aperture. And I think even on that front, it's still a board by board basis, because what might work for one board might not work for the next, depending on the pad size and especially the thermal profile, right?
Right.
Big time.
Yeah, just today, Daniel and I kind of had a little collaboration. You know, he sent me a picture of a pasted board and then sent me a picture of the corresponding component top view first. And it had some metallization along the sides, actually on all four sides. And then the next picture was the bottom of the component. It's like where there's no metal there.
Like, no, that's backwards.
And the footprint and ultimately his pasting pattern had all kind of solder paste underneath the component. So that was really interesting. So we kind of talked through it, and I was like, well, what about this? You know, our conversation led us to think like we need to remove some of that paste from underneath the part, since there's nothing there that it needs to satisfy. Kind of made a quick initial sketch, and then Daniel found the part number, and we looked at the data sheet, and lo and behold, it was pretty dang close to what we had been talking about. So it just kind of made us wonder, like, why is the PCB land one way when the component recommended soldering land was completely different? And I think that's where Daniel was kind of starting this conversation off. Maybe at one point it was a different component or a different iteration of that component, and since it's evolved into what it is now, which is a very strange looking naked bottom component, for lack of a better description.
Because most people have seen that style of component that the footprint is favoring or whatever is designed for. You know, you've got capacitors and filters that have this band that goes down the center. It's pretty common. And so you've got, you know, your typical pads at both ends for your resistor, capacitor, whatever. And this instead will have a narrow stripe down the center that generally corresponds with a metallized part on the component, you know, but this one didn't have it. So the component didn't actually have that band on the center underneath for it to actually form the joint to, you know, it's not a bottom terminated component like you would expect from that footprint. So, you know, it was, at first we were trying to figure out, because what clued us into the problem was on our paste check on our first board, when we sent our first board through the reflow oven and gave it a look, we had some open ends, and we're like, well, that's weird. What's going on there? And so initially, before we like kind of uncovered the whole thing, Elias was like, this is probably another instance where we need to reduce, where when you see an open end, everyone's first thought typically is I need more solder. It's open because it doesn't, you know, it's insufficient solder. That's why it's an open joint there. There's just nothing there typically. It's what we were seeing on certain ones. And so people might want to add, but what we actually ended up deciding, especially confirmed once we looked at it, was that reducing it would help, because if it's not sitting on so much paste in the center, it's probably not going to float above it. Paste will probably flow up the sides better. And when we realized there wasn't an actual pad on the bottom of the component to match the pad on the board, then it definitely made sense to reduce some paste underneath it, because, you know, nobody needs a bunch of solder balls trapped underneath the component, which is likely to happen if there's nowhere for it to actually go, right? So
there's no wettable surface on the bottom of that component.
Yeah, where's it going to go? How's it going to actually do what it's supposed to? It doesn't have a place to do it. So anyway, we'll be getting a fresh stencil hot off the press from Elias soon on that one, and we'll be able to update a future pod with our guaranteed smashing results. So that'll be exciting.
Yeah, this one's going to be to be continued for certain, because I feel as we have a good stencil strategy, but what we can't change is the fact that that entire area is weldable on the board, right? There's no separation there in the middle.
There's no way to stop it from flowing underneath.
And is that board in a NIG coating, or is it hassle?
It's hassle.
So that definitely leads itself to just being prone to wanting to kind of solder underneath right there, at least pad wise.
How did you just say Enig?
Enig?
Enig? I would
Like
say
Enigma.
E.
Exactly. Yeah.
Well, who's right and who's wrong?
I guess that's the
Man,
real question.
This is one time I actually agree with Sean, which lends me to believe I'm wrong.
Oh, man. I got all excited for a second. What do you
I was
think?
gonna say,
That's what I was thinking. I was like, it's the Z versus Z thing all over again.
Ah,
Right?
it's the red versus orange for Pater's headphones all over again.
they're clearly
Well,
orange.
just thinking back to the component thing, actually, it just made me think. I've seen a lot of times. It's not really. I don't know if it's a component going obsolete, but more just a mistake from the designer perspective. But I've seen time and time again the footprint for a SOT 23 diode, and then they spec in a SOT 323 diode, which is just a little skinnier. And depending on the pad design, you can actually get
You
it.
might get away with it.
You can get away
Mhm.
with it, but it's obviously not optimal. And then even worse cases, I've seen a couple times where, and generally speaking, we can cache this at, on the bill of materials, but the odd time you'll miss it. But you'll come across a capacitor or resistor that seems to not want to solder at all. And then you go to the DGT spec sheet and you realize that it's because it's not a solderable component. It's one of those epoxy components. And so therefore it doesn't have solderable leads. And that's an interesting one, right? Because it's just really a part number difference, but everything else parameter wise is the exact same. And you don't really know from a visual perspective. You only know once you throw it through reflow, and then it doesn't, all the solder just sits around it.
Just like repels it.
How does it
Exactly.
actually connect to the board if it's not soldered?
It's like conductive epoxy from my understanding, right?
Because how does
So
the
it's
signal or whatever you're throwing through that part actually go to the traces?
Well, I think it's like the metals are like conductive from an electrical perspective, but I don't think they're solderable, right? Like it's not got the plating that leads itself to the solder actually adhering to it. So it's not that the sides of the component isn't electrically conductive. It's just that the solder basically repels around it. It's like when you have a very oxidized lead, essentially. And that's what it reminded me of when we originally, came across it was, did we just receive a bad component from the manufacturer? And we've even seen where it's, just bad plating, right? I know it's notorious with the Agio resistors, where the resistors will come in and they'll look plated fine, but whether it's like a contaminated nickel bath or whatnot, essentially, it just leads itself to not wanting to solder.
Those guys are AOI nightmares too.
Have you guys come across? See, we've seen it time and time again on their capacitors where it's weird, and sometimes I think it's like a RoHS contamination because on some of the RoHS boards, their capacitors will, after reflow, it almost look like it went through a bubble bath. Like all the solder looks like little balls because it's basically separated, and like the IMCs or the intermediate connections have almost separated from the actual leads. It's a weird little phenomenon. And like from a electrical perspective, it still works, but it's definitely not what I would want to be given to customers.
Well,
So.
we know why the customer wants to use them, right? They're always the cheapest price. But I try to stay as far away from them as possible because there's no identification marks. That's my main qualm with them.
I'm a big fan of Panasonic and Samsung. I mean, Samsung is nice because their reels are very bolded in big letters, 22 ultraferret 805. So just from an inventory perspective, it's super easy to see, where Panasonic obviously is very notorious for having fairly good quality. But the thing I like about them is they're very descriptive on their reels. So they list everything from tolerance to, the values, and it's listed very nicely. So again, when you're receiving a lot of times like new components in inventory, it makes it really easy to, let's say when you're adding your barcodes into your IT systems to have it so that's, queryable.
Are you saying on the actual tape itself, or are you saying on the packaging you receive it in?
Like literally
On the reel?
On the reel itself. Yeah,
Wow.
like the manufacturer reels. Like I know DigiKey recently started on the back of their
Not all
tapes,
of them,
though.
yeah, but yeah, they have.
Yeah, it's like they have some kind of stipulation on it. I don't remember what it is, but I've noticed it recently.
How much influence do you guys have in that decision-making process in terms of what manufacturers' parts are being used typically?
Me, none.
I can
John?
suggest, and then I'll give that customer those reasons we talked about today, of quality, and the main thing too is identification. It just
And what phase are you making that suggestion?
right at quoting, right away. Yep, and we'll send a quote out, and then we'll also say, we might even say before we send the quote, we'll say, hey, can you accept alternates on any of these parts? And we'll list I don't even know how to say them. Waigo, I don't even know.
Wagyu, like the good beef.
It's like YAEGO, right, Caleb?
Yeah,
GEO.
YAGEO. Yeah. I've always said Yagio, but I know that there's a couple different pronunciations for it. All we need to do is watch like a factory tour once and then just listen, and then we'll have it.
Yeah. We'll do it during quoting, and then I'll try to tell them the reason why.
I should have been. I said no, not for me, because that's not part of my gig. But they definitely will do that on the quoting side too. Like if there's, especially, like we'll run our stuff through, the software that tells us whether some parts are going obsolete, some are close to end of life, some are and so if they have a design that has parts that we can prove to them, hey, this is going to be really hard to find. Maybe right now we can get them, but if they're not going to be making them anymore past this date, you can count on it's going to get harder and harder to find them as time goes on. Maybe we can introduce an alternate that's going to, satisfy the, design's needs, but also be attainable. You'll be able to purchase it. You'll have a stronger supply chain, more secure. So they'll definitely recommend those kind of changes in the other part of the office, not my portion. But and once it hits the floor, then we'll also definitely suggest changes. If it's hit the floor and somebody on the front end didn't catch that it's not the optimal setup, like I don't know your experience, but if I don't have the perfect lead thickness compared to the via size, I get unhappy. Like things like that. If it just anything where if they would have used a different manufacturer, things might have been a little easier. Like it's always good to recommend those things and see if you'll be allowed to use it when it's not your own design.
Yeah, they're significantly cheaper though. That's the issue too. Is when the customer is at a certain price point, especially in lower quantities. And it's funny because Caleb earlier talked about a $2 resistor, right? Each. I mean, some of these are 0.00, or 0.002 cents, right?
Fractions of a penny.
Fractions of a penny. So $2 is like pretty exorbitant.
Yeah. So, but yeah, if you're counting your pennies though, if you're counting your fractions of pennies, they're definitely the cheapest most of the time. So. There's so much you can do.
I just got distracted by an alert. You're going to be able to get your baby formula again, Sean.
Nice.
Hey-o.
I got four cans. My mother-in-law got 4 cans for me too, so I'll be set up for like 3 months.
I just got an alert that the port workers strike ended, which will be old news by the time you guys listen to this.
Yeah, it did.
You want to know the worst part about it is I found out ours is actually shipped because they're manufactured in Australia. It's shipped to the West Coast. It's literally just Amazon restricting the supply. And
it's completely artificial.
Yes, 100%. It's they have all the stock that they need. I mean, probably they sold a whole bunch because everybody panic bought, but it's not affected by the port strike. Because my wife emailed their Instagram account and their main account and got the skinny on everything because they changed the packaging on it. She wanted to make sure it was the same kind, blah, blah, blah. But, yeah, so I know way too much about Australian goat milk baby formula. The supply chain of it. So, yeah. But Caleb, one thing I really want to pick your brain about, this thing that I respect about you a lot, especially for your young age, is I know you're heavy into Lean, Six Sigma, Kaizen. For you personally, what is the best for our industry that you've felt that could be implemented? And you could say all three or whatever, but I was just curious if you had to choose one of the three things to implement more heavily in your shop, and then if you could give an example of anything you've done in your shop using any one of those three.
Yeah, I guess truthfully, I think from my perspective, I mean, for a simple answer, it would probably be Kaizen. But I mean, in reality, kind of to expand on that, it's really ultimately continuous improvement. And that's both from a perspective from, let's say, quality to throughput, but it stems more than that. It kind of lends itself from the operations perspective. It's really catering towards making it easier for your employees. And ultimately, that leads to higher satisfaction of your customers, right? It's taking the guesswork out of the operations most of the time. What I find from our perspective is when we have a quality issue or a process issue, it's a lot of times in most companies, for lack of a better word, the flows downhill, and the blame gets put on the person doing the problem. Where in my perspective, it always goes up. And so if someone was led to a spot where they were able to make that mistake, it's not how do we shame that employee for making that mistake? It's how do we constantly improve to avoid that mistake going forward? And what do we implement within that process, or what might be to avoid that in the future? And that
if
goes.
They were confused, you need a better process, right?
Exactly. And whether that was from a training perspective, lack of documentation, it's catered to every situation, but it always stems, what can we do to basically eliminate that going forward? Whether that be a tombstone on a board and adjusting our stencils, to using a different manufacturer for our resistor. And then moreover, it's a lot of times it really stems just from the actual employee processes. If someone's having to walk 20 feet to grab a label, to then go 50 feet to go grab the tape, to then go find the box, to tape up a box and pack a board, well, we should probably eliminate that entirely and put it all for them to be able to do it all efficiently. And that's really what we kind of strive to do, is really optimize for efficiency and ease.
People will respond a lot better to corrective action if you're not blaming them for all of it, right? If you're taking ownership of, hey, you made this mistake because I didn't lay this out right for you, we didn't have good enough documentation. We need to do better providing you what you need. If you're sharing in the accountability for that problem, you probably aren't going to experience a lot of pushback from them. And instead, you kind of, breeding a culture of partnership and teamwork rather than blame.
Exactly.
Now, do you feel the only way to truly get a grasp of that is actually have your hands dirty on the floor? Because there's some people who try to micromanage from above, and yet they're not involved. They haven't worked their way up from like the bottom to where they're at today. They just get thrown into these positions. And I almost feel like you'd have to be in the field. I say this all the time. People in my shop, I try to get them to see the whole vision, right? Because I've done it all. And so they don't see, hey, by you doing this, you're going to slow down through-hole production because they need this board because there's these leads on this came in bulk. So we have to bend them all one by one, right? We didn't get these in ammo. The customer supplied them in bulk. So now I need more time in this department. And unless you're involved in that day to day and have done that stuff before, you really don't understand the full concept of what you're asking people to do, or where you can even cut or even improve on that process. Because if you never did shipping and receiving and you were just told, hey, tape's over here, box over here, and it wasn't and you didn't have the freedom or the voice to say, hey, let's move this stuff to here together. I know it's a simple example, but you can apply it to anything. Do you feel that same way, that you have to have your hands dirty in the process in order to truly understand where to cut and where to save and how to improve?
I think there's kind of two answers to it, right? If you're coming from the business operations perspective, it kind of can vary. And I say that because a lot of times, one thing as you scale as an entrepreneur, you have to realize there becomes a point where you have to choose to not work in the business. You have to work on the business. So a lot of times that's the biggest hindrance for a lot of entrepreneurs, is kind of jumping over that hope, is stopping from being an intrapreneur and really becoming an entrepreneur. But with that said, that's kind of in the bigger picture. And that's what makes a good leader, is kind of to what you said, Sean, is ultimately your ultimate responsibility as a leader not only is to take ownership, but is to truthfully cast a vision. It's to lead a vision for your team where they want to follow that vision and they execute your vision to the way that you need it to be done, right? Because that's the only way, again, is no matter how good you are at anything, you can't do it all yourself.
Right.
So you have to be able to figure out a way to have a team that can execute on your behalf, that can kind of live, beyond you. But from the same perspective, when it comes, from the actual nuance of processes, I think 100% you can't nitpick the processes or the improvement of employees and such without working in the business or actually doing that job. I guess I'm sure there's outliers out there, but I think a lot of times if you aren't working in the business or understanding the true pain points, there's not a way for you to give a full, proper outlook on what needs to be done to fix those pain points. So that's why, again, kind of to what you said, the one thing I always try to make very clear, and I make it, very evident in our business, is there's nothing in the business that I'm too good for, so to speak, right? There's nothing that I say isn't my job, whether it's mopping the floors to putting ESD tape to packing boards, right? You'll catch me do every single job. And that's that's just the way I want to operate, but that's also because that's the best way I can find to continuously improve everywhere within the business, because I can kind of find the pain points. If I'm wondering why an operator's having issues packing or his speed isn't fast enough at the through-hole line, but I am not aware of how the actual process works, how can I sit there and criticize the time, right?
Yeah.
And it's not until you actually do the work and then you go, oh, wow, this is really strenuous on his back. Maybe we should have a chair for him, right? Or vice versa. He's having to reach for this part behind the machine. Why are we doing that? We should have these parts readily available to him so he doesn't even have to turn his head for it, right? It's the little things like that that I think a lot of times get forgotten.
I know Sean said, like, oh, that was a simple example or whatever, but realistically, that's what most of these changes are. They're extremely simple changes made from either an observation or whatever, but it's not like some novel concept really to put the things that go together. I mean, it's like, yeah, that's a simplified way of saying it for sure, but really the principles that you're applying are very simple.
Well, and I was going to say too, because like when we were talking about, Sigma and Kaizen, what you see a lot of times, especially in the corporate world, is these companies have what's called a Kaizen day or a Kaizen week. And that's a really bad way of going about it, because what they do is they basically implement a massive amount of change all at once, and then they nullify it. They're just kind of stagnant
we make
for a while.
continuous improvement once a year.
Yes, exactly.
Which is right there.
Right? Where it should be the quite opposite. It should come to that point. It should be very, very small improvements, but constantly and everywhere in the business. And that's really what it is, right? What builds a big business and a great operation isn't going to happen overnight, and it's not going to happen in a year, right? It's going to happen over a long period of time with continuous learning and improvement. And, failures are going to come along the way, but those failures are what lead you to improvement, right?
Yeah, and you always figure out it's the stencil's fault,
That's right. That's the benefit of learning.
I think I read somewhere like 99.9% of surface mount defects are because of poor stencils.
And packaging issues and
I tell you what, I did shipping and receiving for 13 years, man. I am the fastest gun on this side of the Mississippi. You can solder better than me, but you ain't. I'll whip a 8x8x8 box in less than 20 seconds. Just pop, 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 done. And you could throw it like a football after it's packaged too. That's how.
See, it'll surprise you. See, that's why I say business is a game, because I'm competitive, and that's the one thing that it's a blessing and a curse, because what they say also too is one thing you can never forget is the enemy of profitability is perfection.
Yeah.
So
that's a good one.
It's a really good saying, but at the end of the day, you kind of have to pick your battles. But one thing I always strive to do is, if I'm going to do it, I'm going to try to be the best at it. So when I do something, I'm going to do it pretty damn good. And the one thing I always say too is I don't know everything. Of course I don't. I'm 27, right? There's a ton of learning I have to do. But when anybody has a question, I'll always be able to find the answer. because that's kind of the way I work. My brain itches when I don't know the answer to something, so I have to figure it out. But that's kind of what leads you to just constantly wanting, to get to the next best thing.
So you just moved recently, so I imagine that provided a pretty good opportunity to kind of address some of these pain points that have popped up, and starting with a blank canvas. Tell us a little bit about that. Was it a pain in the butt? Did you like it? How did it go?
What a dream.
Doesn't everybody love moving? It's yeah, to say the least. It was. I wouldn't do it again anytime soon. I'll put it that way. It was quite the move. But you know what? It's at the end of the day, it was 100% for the better. To your point, we implemented a lot of, from the business perspective, it was a lot of background implementations that is going to, in the grand scheme of things, make it a lot easier to scale. And it eliminated not only a lot of the pain points, but it really introduced a lot of redundancy. One thing that I think we found in the previous location was we kind of had a lot of eggs in certain baskets. So we obviously had our dedicated shipping room and our shipping computers. But what happened when that computer decided to not want to wake up today? Well, now you can't print barcodes or shipping labels for your customers. And so it was the little things like that where it seems kind of futile or simple in the end, having a lot of backups and redundancy for pretty much everything throughout the business is, like I said, is a huge plus from an operations perspective. But again, what it really helped to do is spring cleaning. So it was really kind of give us a fresh start, that blank slate, and eliminate a lot of the junk that was unneeded, eliminate a lot of the things that might have been kind of complacent up until this point, that now it was the time to really kind of eliminate it. Let's start fresh and kind of introduce a new way of doing things. What we really did was, because we were coming into a new building with a custom facility, was obviously everything was going to be very clean. So that's the name of the game, is keeping everything extremely neat and clean. And that goes for machines, workstations. Everything has its place. Everything gets put away and back to where it needs to go. Kitting is to the paramount, that when a project's done, any excess gets kitted back away. So that essentially, at the end of the day, it's like when we walked in the first day that we got the building. Everything is kind of in its shelf and nothing is kind of laying around. So
that's beautiful.
It's I've got to upload some more videos or photos of the facility, because it's I'm pretty proud of what we kind of accomplished there. Mm-hmm. It's quite the facility that it's definitely something I like to bring customers through. And we've done things a little differently than most. It's kind of how we do things. We went around and bought another pick and place machine. So now we've got, our normal dedicated surface mount line, but now we've got a secondary pick and place machine that we use strictly for prototypes, and one-off builds, and then obviously programming and teaching. So that obviously gives us that ability to kind of do things in tandem, not take away from our volume production when we're having to spool up MPI products. And then it also gives us that flexibility that if we do have a customer that's, fairly demanding and requiring a high throughput, we can run double the amount. But on that same vein, we've got separate rooms for rework, calibration. Everything is very segregated, which leads to a very clean environment. And, just overall, it's a nice morale.
Yeah, that's what drove me nuts about your post today, to be honest with you. I've seen glimpses, right? And Daniel, I don't know if he showed you the new pick and place he has, how quiet and fast that thing is. And it was a beauty to watch. And then I see it, and he's got a post with 10 words on there, and I'm like, what is going on? I finally see your name pop up on my feed, and I'm like, okay, it's gonna be something. And then it's that. And I was like, so yeah,
we'll get some good videos out there. I definitely want to. So it's we've been driving that thing full blast since we've gotten it. So it's been a dream having it.
Do it, or Elias is gonna block you, he said.
Oh yeah. Oh, it's always nice when you can eliminate single points of failure as well, right? You mentioned that with the shipping computer, and now having a second pick and place. Like, what if you have one, you have none sometimes. If it goes hard down, then there's no redundancy there. So I can appreciate where you were driving with the point of having redundant equipment or redundant shipping stations or whatever it may be. Anytime you can eliminate that single point of failure, you sleep a little easier at night.
100%. And it really started to click to me because it was one of the things that I noticed a lot of times. One of the first questions that a lot of customers would ask when you kind of have one line or one machine or, to that point, kind of a single point of failure is that's what they're always asking for. Is I used to think it was, well, you're not busy enough from that perspective, but that's not at all what they're asking for. They're really looking for what is their failure point, what is their, essentially liability, going with a contract manufacturer that, might have a little bit of a pain point in that perspective. If they have a crucial order and unfortunately something goes down, how are you going to rectify that? Right. So.
Yeah. Is there continuity there? Can you continue on if something goes awry? Exactly.
So many big words.
That has 4 letters.
Continuity and awry?
Yeah, awry's not a big word.
That's a big word. You're not using that in your day-to-day vocab, let's be honest.
There's probably one person in this recording that would not use that in their day-to-day life.
Who?
Yeah. Okay.
So, hey, don't be using big words.
Okay, so how about let's throw Elias a bone, some stencil talk, home plate, or anything like that, or versus Sean's school of rock, squares and rectangles.
Yeah, I mean, I guess it depends on what it is that you're trying to solve for or avoid, right? So a few different techniques of home base or home plate. Are you trying to avoid or eliminate solder balling? Then we're going to look at going with the inward facing inverse home base. Kind of imagine 2 Pac-Mans looking at each other. If tombstoning's the primary concern, then take that same design and make them so they're facing away from each other, right? So an outward facing inverse home base is an effective design for that. Sean goes pretty much full paste on everything and says he never has issues with either one. So I mean,
he says send it.
Yeah, and to be fair, that's the experience that I have day to day. Is there's oftentimes, more times than not, variances from customer to customer. They each kind of have their recipe, they have their strategy. It works for them, and it's very personalized. Kind of like in the beginning of this conversation, we were talking about selective and how you would each probably take different approaches, different strategies, and end up with a good end result. Stencils can be very much like that. There are some well-known best practices. There are some rules that you should probably not violate, but there is a lot of leeway there as well. And different folks have different strategies, and you can't argue with results.
100%. Like one of the things I find too is it's because it's so dependent on your process, right? Like I've seen a lot of customers who, if they have like a board that they're going to be cleaning, so let's say it's a no clean board, they might lead themselves to doing a lot of overprinting, right? Just because they'll get some nice fillets, and then any of those little residual solder balls are just going to get washed away. Where like for us on the flip side, because we use no clean strictly, and a lot of times we don't clean our boards. What I'll do is a lot of times we have a reduction on the pads. So on the flip side, we'll actually add, it's the preforms after. So with our surface mount line, we're sending solder preforms into the paste, and that's where we're getting our additional solder paste. So that way I don't have to do like an additional step up anywhere, because I find a lot of times our boards are so densely packed that the step up is going to be a confliction with something fine pitch very close to it.
Something around it.
What's a preform?
Basically, it's just a little brick of solder, and you can get them in the size of like 603 or 805 or whatever size you want. But just picture a capacitor, but it's strictly just solder, and it's just a hard form of solder that you can pick up with your pick and place, and then you place it in your paste, your plate paste, and then that just gives you additional solder volume. So it's most used a lot of times. You'll find it used a lot of times in pin and paste.
Is this after paste or?
Yeah, so basically the way you would do is at least for us, what we'll do is like you're gonna paste your board how you normally would.
Yeah.
And sometimes you might do a little bit of an overprint towards the rear so that you have almost like a little pocket to drop the little bar in. And then so on your pick and place, in the same, let's say on your chip shooter, where you're gonna be placing all your resistors and capacitors, you're just gonna have a feeder that's just full of a reel of solder bars. And you can use those a lot of times. Is what they're most known for is for pin and paste. So when you have a board that you're placing a through hole component in, a lot of times that solder overprint isn't going to give you enough volume to give you good hole fill. So you'll use a preform to give you 100% hole fill. But the other use case that a lot of people don't realize is on large capacitors, like tantalums, for example. And it's more geared towards like class 3 assemblies where you need like very high
where it requires.
Yeah. So in those cases, rather than touching the board by hand afterwards, right? Because a lot of times, especially if you're dealing with space, they might even tell you that it's restricted, that you can't hand solder the capacitor because like there's the chance of, overheating the capacitor because you're diminishing it. And so therefore you have to use basically a preform to add some additional volume.
Now, is this stored in the refrigerator like normal paste?
Not at all.
It's in a reel.
It has like a shelf life of like 4 to 5 years. It's it's the equivalent of your solder wire.
That's all I'm running from now on then. 4 to 5 years, boys.
Oh,
I will
yeah,
say
like no stencil even, you're saying, Sean.
Nothing.
You're saying you're just going to...
Straight preform.
But see, the beauty, we'll take it one further. He's still going to need Elias's stencils, but it's only for flux. He's going flux only, and then he's just dropping preforms everywhere.
Boom. There you go.
I've heard of that flux only process. Interesting.
Have you done that at all, Caleb? Flux, using a screen printer to deposit flux?
Never. No, not at all. The one thing I actually just recently discovered, though, was have you ever heard of Z-tape?
Z-tape, it's called.
Z-tape. What is it? Have you ever heard of Z-tape?
I've never heard of it.
No?
Z or Z.
So this is something I just came across, and it's honestly going to change my world for prototyping. So Z-tape
I'm so excited right now.
It's a 3M conductive tape. It's like, call it 2 or 3 mil. So once it's on a surface, it's basically virtually, it doesn't add any height, but it's conductive. And what this lets you do is you can layer this on top of a board so that for a prototype, you can now place all your components, and now they're stuck to the board, and they'll conduct on the pads. So you can do a prototype build without any solder, without any epoxy, without anything, without any reflow. And obviously this is not for production or volume. You would only do this for, quick prototyping. So, but the beauty is this gives you that ability where, let's say you place
without
all your
even
components,
consuming components, right? Like
exactly. You can remove components willy-nilly if, let's say, you're prototyping and you need a value change, you pull it off.
Wow.
Changes the game.
Big time, man. Especially because I have a customer.
Elias, start selling it, then you'll like it.
Start making it.
No, I'm wondering how if the tape is conductive, how is that not just
You said it was
city, right?
So what it is the way it works is it's tape with tiny little balls. Call it solder balls, but they're tiny conductive balls. And the reason it's called Z-tape is all they do is they collapse in the Z direction. They do not collapse in the X or Y. So when a component's placed on it, it smushes in, and that creates that conductive connection on the pad. But there's spaces in between the actual, individual balls. So the tape itself, if you took a multimeter from one side to the other, it's not conductive to each other. It's only conductive once it basically a Z force has been pressed.
Wow.
And thus the name Z-tape.
That'll probably be our first sponsorship. So go ahead and put that right on the screen for us there. The link to buy that'll be perfect.
We got Pillar House, we got Z-tape. We're just ranking them up today.
It's not even that new. I'm seeing an article here from 2019. How none of us heard of this? Is this a Canadian thing?
That's kind of how I felt too, because I don't think it's like a new thing at all, and it's like readily available from 3M too. So it's not like it's some rando crazy thing. I think it's fairly common somewhere, obviously, if 3M is a major supplier of.
Elias, do you understand the difference between Z and Z?
Yes, I do.
What is it?
There is none.
See, but do you know why one would say Z and one would say Z?
I guess it just depends on what.
I'm so
part of the world you're
riveted right
from.
now. Please. Yeah.
Okay. Daniel, do you?
Like call letters or whatever for, like using Greek letters to like differentiate a letter from a,
You're falling
like
right into his
C
trap,
or
dude.
Z or whatever or what.
Got him.
That's logic, right?
Got him. Caleb, tell him why.
Well, if I know.
Well, Z, they say that's how they say Z in Canada.
See, that's what they say, but I don't know anybody that actually says Z. Like, I think it's kind of like a myth, like the whole boot thing, because that's not real either.
Maybe you're not in the real part of Canada.
Well, yeah. Listen, guy who lives in Canada, you're wrong. You don't know Canada like Sean knows Canada. All right.
Let's not forget,
Just
I am from Texas,
trust us.
so maybe that's all it is, right?
Yeah, you're wrong. I know for a fact.
This tape is so cool.
I think I've changed Elias's life with the tape.
Look at him just going to town.
Yeah.
Changed my life.
It's available
Well, I
on
know-
Amazon. I don't know what I need it for, but I'm going to buy some just because it's so cool.
I'll be honest, that was like when I first heard it too. That was why I grabbed some and I was like, I don't know when I'm going to use it, but I'd rather have it than not need it than need it and not have it.
Do you
So,
place it with your pick and place, or is it?
in reality, you just basically like lay it, like you would just tape over the board with it.
The whole
So,
board.
Yeah, it's basically just like a little sheet. So you buy them in like these sheets, and it's just like this adhesive
And
that
then
you
you
place
run-
over the whole board.
And then you run your pick and place,
Exactly.
and you don't have to reflow.
Nope.
And
And
it
just,
stays.
just the force that the pick and place exerts downward is enough to kind of activate those connections.
Caleb, you're not
So-
shipping a board like that. You're just you're testing that
Exactly.
in-house.
This would,
Right.
I mean, like, obviously that would be up to you to talk with your customers, but yeah, this would be only, like, if I was to ever use this, it would be for internal only. So
No, I
in
just-
reality, it would be like to test designs, right? It's a really good way to basically kind of branch off from a breadboard without doing a fully soldered board. on this
That's
one.
awesome, man.
Yeah, if you've got like specific potentiometer values or something you're trying to figure out, or you're like, we have some boards where depending on a number of things, it requires different resistors to get put on different versions and all
Yep.
that.
I was just about to
And-
say we have the exact same thing.
Like, man, you could really cycle through that a lot quicker in the development phase
Yeah,
with some
like,
stuff like that. Like,
we
I
have a
can
product
my
that-
mind's just spinning on how useful that could be.
Well, that in that exact purpose, right? Like we have a board that we have probably, I think it's 10 different SKUs of, and there's a couple other components, but the way our programmer works is we have a custom built Raspberry Pi, and that Raspberry Pi, all it does is once you plug into the board, it looks for a resistor value, and that's like its ID, and then that tells you what kind of board it is, and then that then goes into a folder and picks the right proper code, and then loads it to the board. So, but to that point, I'm sure that was kind of a pain to, troubleshoot and deal with on the bench when they were, first bringing that up. I can imagine having the Z tape just, check this resistor, try this one, change the code, try this one. It'd be quite the
That's a game changer.
difference.
Mm-hmm.
That was my input for the night.
No, that was
That's
great.
a good one. Sean's still thinking about preforms.
No, I'm thinking about what type of carrier I could put it in to ship it. How I can make a
A
custom
tape
carrier.
board.
Like, well, you know how like I kind of did the dropout for you, Daniel? Where you drop it in, right? I wonder if I could drop it
I've
in.
never bought anything from you.
You didn't buy it. I shipped it for you for free. I know. Trust me. I'm well aware that you have never successfulully purchased anything from
That's
me.
right. I did get it for free. I was trying to make a joke, but I forgot you actually did give that to us for free. So I really haven't bought anything from you.
I used it 90,000 times. Just like, oh, thanks.
Oh,
It's
that
a
was
game
a
changer.
fun accident.
Yeah. Made his life
Yeah.
so much
Well,
easier.
hey, anyone who needs literally only one carrier, like Sean is the guy to go to.
Yeah.
Because he'll give you that first one for free, and you're good. That's my piece of advice
Well,
to the public for the night.
I talked about this with Caleb a long time ago because you do those fancy, what do they call it, Duracell or Duratray or something?
Yeah,
Durastone, something like that.
Durastone or whatever. Yeah.
Durastone, yeah. But I just use regular unclad FR4 and I route it out and works great.
It's awesome.
But I know the difference between you and me is I'm the high mix, low volume guy, and you're doing a lot of high volume, low mix. So I have some pretty brown carriers, man, that I've ran through a long time, but those carriers don't sit the board into it. Those carriers are just literally around the rails of the board, and they just kind of form a square, and I just kind of put that through the conveyor.
Did I ever send you pictures, Sean, of the other carriers that we did buy?
No.
The process carriers I was telling you, they actually you can put them in before your screen printer, screen print your board in the carrier, go through the pick and place and the reflow. Like you can go through the entire process. It can handle the reflow temps, and the board sits flush with the top of the carrier, so there's no issue with the screen printing or anything. Like they're pretty slick.
We just had to actually design a custom one because we have a customer who's consigning a product to us, and they get their boards in non-panel form, so they're individual boards, and it's a double-sided board, and it's impossible to process through our paste line. And so we developed a jig that has 4 basically pockets so that we can put 4 boards at a time. And then same idea, it's just got 1.6 millimeter pockets so that the board sits nice and flush. And then it's just got cutouts for the bottom where the surface mount components are. And so we'll run that through the entire process. And then like on the flip side, I have those Durastone jigs that we basically have that they're really just call them flat plates. And they just have a ton of holes in it to promote airflow. And all they're there is to avoid bowing on the boards because our oven doesn't
give it a solid surface to...
Exactly, because we don't have a conveyor chain. We only have the conveyor rails. And so when we bought our new oven for that, I obviously needed to figure out a way for single-sided boards. How do we avoid the bow? Because like it's most prominent, for certain boards, it's not a big deal. But most prominently when you're trying to do selective, you really cannot have a bow in the board, or it's just
I'll have to get with you on that because like we have some ceramic boards that we do that are just so crazy fragile. Like, yeah, I swear if you look at them the wrong way, it creates a hairline fracture in them, like it's just so having a solid support, to run through the whole process, not just, like I could see how beneficial that type of carrier would be in a number of ways.
Well, you're aware that you could take that same unclad FR4 I sent to you straight through the oven too?
Yeah, I mean, that one I do. The one, yeah.
Yeah, so I don't know why you guys are going all this fancy route.
I was going to say, like, the FR4 is the way I've done. We had a couple boards where...
because it's adjustable, Sean, to any size.
Oh, really? You left that part out or I didn't hear it? Oh, my God. Okay.
Yeah, it's a universal carrier to fit a huge range of sizes.
Yeah.
You can move it in the X or Y to whatever dimension you need and lock it in place and all that. Like they're slick.
Well, mine's adjustable if I make a new one with a different size.
Yeah. If you design and get the material and
semi-automatic, yeah.
Well, Caleb, unless if one of these guys has a pressing question, I think we've taken up enough of your time. Like I'm super grateful that you were willing to join us and talk the PCBA world. I'm sure we'll have you on again at some point when we start cycling through people because we get along great. You have plenty to talk about. We could have talked for much longer, I'm sure. So thank you for making the time. I know we were going to try and do this a couple times. So finally worked out for all parties and really appreciate it from our end. So just want to make sure to say thank you and give you this opportunity to talk one more time if you want about GenPack and what you guys offer. And thanks again.
Yeah, well, like I said, I really appreciate you guys having me, and yeah, by all means, I'd love to come on again for sure. And if you guys do want to check us out, you can find us online at gen-pack.com. So that's GenPack Assembly out here in Ontario, Canada. And like many of you guys, we're a contract manufacturer. but a little bit different. We kind of service our customers. So we, a little bit more than most. We like to be an extension to our customers, and we really like to cater towards their needs. So like, as Sean said, we're kind of more towards medium and high volume and less mix. So that way we can really, improve with each and every project that we work on.
Beautiful. You guys have anything?
Thank you, Caleb, man. You were awesome.
Yeah, thank you.
That was a pleasure.
Great speaking with you.
Especially for your age.
Thanks, Caleb.
It's very impressive, man.
So for the Decode Podcast, Rev 1.9, thank you all very much for tuning in. We'll see you again next time.